simulation analysis. Simulation analysis. Right there, today's date. Write today's date. Simulation. What you're supposed to know is that to simulate is to imitate. To simulate is to do what? To simulate is to imitate reality. So write for us there that to simulate is to imitate reality. Is to imitate reality. And that is why you will get even children working with the toys. So they have a toy car, they're basically imitating a real life scenario. They're imitating a real life scenario. They're imitating a real life scenario. Now, ladies and gentlemen, listen and listen to me very well. If, for example, today you are to go to some good driving school. If you go to a good driving school, these guys will not take you to the road immediately. What they will do, ladies and gentlemen, they will come and they give you, for instance, a table roundabout on paper on your table. And then they'll give you a toy car. They'll tell you remove this toy car from this particular position to this position like that. At first, because you are inexperienced, you may even think it's about shortcuts. You'll come and move this vehicle, and then they'll tell you, no, gentlemen, there is what we call, for example, keep whatever. Keep whatever. So they use this particular imitation to ensure that you'll be able to learn a real life situation. You'll be able to learn how to, for example, drive now a real car. But first of all, we start from paperwork. And there are so many imitations. If, for example, today you are to go to the University of Nairobi, second year, medicine students, these guys are never exposed to real human beings. They will imitate, for example, if they are doing anything surgery, they will at times, in this case here, get rabbits and dissect them like that. They try, in this case here, looking at their kidneys, etc. So they'll have to use those dummies for them to be able to get experience, which is needed for them to be able to act on a human being in the future. So we are saying very importantly that to simulate is to do what here? Is to imitate reality. Now, ladies and gentlemen, what are we required to know about this for our exam purposes? What we're required to know is how to generate random number, ranges. So right there for us, random number ranges. Right there for us, random number ranges. So random number ranges, what do we have here under random number ranges? You'll be given a variable like price. Somebody, ladies and gentlemen, wants to start a business of selling this kind of pens, So this kind of pens, he may not be knowing the exact price, how much is to be charged. So what this person will do, he'll walk around, get shop A. So shop A, for example, is selling this thing for 10 bob, shop B 20 bob, shop C, for example, 30 bob. So using the frequencies, this person will be able to come up with probabilities. So probabilities will be given for us here. For example, we have 0.3, 0.4, and then 0.3 lastly. So please write this as an illustration. Write this as illustration number 1. And here will be required to generate or determine random number ranges. Determine random number ranges. So this will be given in your exam. They give you the random variable with their corresponding what here? Probabilities. So once you are given this kind of a thing, how do you get random number classes? Ranges are as well known as what here? Classes. The first thing that you will do, ladies and gentlemen, is to come and give us our cumulative probabilities. So come and give us cumulative probabilities. So give us cumulative probabilities. So cumulative probabilities, what do we have here? We accumulate these downwards as we add them. So we have here 0.3. Come and add this here. This gives us 0.7. Add this here, which gives us 1. What here? 1.0. So the first step of getting random number ranges, ladies and gentlemen, is to ascertain cumulative. Write this in full, cumulative probabilities. Now from there, you will come and give us our random number ranges. So our random number ranges, how will these random number ranges, ladies and gentlemen, look like? Random number ranges are quite easy to ascertain. Random number ranges, ladies and gentlemen, what you'll do, you'll just need to see the degree of decimal places. So we have here the decimal places here. Listen and listen to me very well. If you've got one decimal place, you'll be having 1-digit ranges. So if you've got one decimal place, like now here, these are 1 decimal places. If I've got 1 decimal place, I'll be having 1-digit ranges, which will be running from 0 all the way to 9. 0 all the way to 9. I want to imagine that you guys are taking your notes. You're taking your notes. So 1 decimal place, 1 digit, which will be having, knocking us all the way from 0 to 9. Ladies and gentlemen, how about if we have got 2 decimal places? If you have got 2 decimal places, then we'll have to use 2 digits. If you have got 2 decimal places, we'll have to work with 2 digits. And these 2 digits will move like this. We have 00 all the way to 99. These are 2 digits. These are single digit, 1 digit. Now, ladies and gentlemen, kindly have a look at this. I've been able, of course, etc. It is 3, like that, etc. Now here, I've been able to have my cumulative probabilities. I'll be able to extract my ranges, my classes from the cumulative probabilities, but we are saying that the fact that we'll be looking at the decimal places. So like now here we have 0.3, 1 decimal place. So it means that my first class will be starting from 0, 1 digit. Starting from 0, 1 digit. So if that is the case, then we'll talk of 0 all the way to, we have this upper. The moment I understand how we normally get the upper limit, I will have understood the entire of simulation analysis. Ladies and gentlemen, we have here these 3. To get the upper limit, you read this as if it's a whole number. So if I was to read this as if it's a whole number, I will get what somebody there? 3. I will get 3. So to get the upper limit, I will read this as if it's a whole number with less 1. So 3 minus 1 gives us what figure somebody here? It gives us 2. Now look at the next class. Listen and listen to me very well. The next class will begin from the next number. The next number on the number line after 2 is 3. So the next one will be 3 all the way to 7 minus 1. So 7 minus 1 gives us what figure somebody there? It gives us 6. Now we go to the next class. The next class, ladies and gentlemen, will begin from the next number, which is 7. So we have here 7 all the way to the upper limit. To get the upper limit, you read this thing as if it's a whole number. So 10 minus 1 will give me what figure somebody here will give me 9. Because I've seen some great friends of ours who have just joined us, I would want to repeat a little bit. We began just here where we mentioned our today's topic is simulation analysis. And we say that to simulate is to imitate what here? Reality. Even yourself, for example, if you would want to become very serious lecturers in the future, you must be imitating mwalimu here. Right? At times you get, in this case, even before your classmates, like during those days before COVID, when you used to have a whiteboard, Yeah, you just get a marker pen and go and start teaching. So you imitate a real situation. The moment you do such imitations on anything, at the end of the day, you will become. And we gave a very good example of if, God forbid, you became sick a little bit, you become sick a little bit, and you're feeling some pain somewhere around your kidney. So you go to Aga Khan Hospital, explain to some young doctor who is there. Nowadays, there are very many young doctors, very many young doctors. You explain to this young man, you can see he's barely 24 years, that you've got some pain somewhere around a sensitive organ. And then this young man tells you, hey, that is the surgery table. Go and lie down there. And then he starts producing his scalpels, his knives. Will you accept really to be operated by such a young man without even undergoing any tests? No. What you will do is to tell this young man, at your age, you're supposed to be operating on cats, rabbits, not human beings. Allow me to seek for a second opinion. Allow me to seek for a second opinion. What am I saying, ladies and gentlemen? For medicine purposes, learning purposes, these students are normally given dummies. So when they work on those dummies, they're imitating reality until they get to learn their stuff very well. That is when we shall be able to subject now a real human being under their analysis and their scrutiny like that. Now, so here we are. What are we required to understand about simulation analysis? The first thing, we must know how to get random number ranges. And the random number ranges, I gave these students of mine an example that you guys also have to write down. I gave them an example that you guys need to write down. I gave them this example. We have a business variable, which is price. So this price we are given here, price could either be 10, 20, or what? 30. Right? Probabilities are given. These are probabilities that are given in an exam. And then somebody needs you to come and determine the random number ranges. Somebody needs you to come and determine the random number ranges. So somebody wants you to come and determine random number ranges. The random number ranges. You shall be seeing what we shall be using these random number ranges for. These random number ranges, we shall be using them extensively in simulation analysis. You must be at a position of knowing how to generate them. Ladies and gentlemen, if I'm given this kind of a series, and then somebody tells me to get random number ranges, there is something very important here that I will have to remember, what we call the decimal places. Decimal places will always govern how I will be writing my ranges. If I've got one decimal place like this, one decimal places like that, then I will be offering what we call one-digit ranges. And the one-digit ranges will be moving from 0, this one digit, to the upper limit, which is 9, still a single digit. The same case for two decimal places. Two decimal places, you've got how many digits? 2 digits. And we shall be consistent like that. So 2 digits, we have got 0, 0, all the way to 9, 9. 0, 0, all the way to 9, 9, like that. Now, I would want to make this a little bit practical. Allow me to make this now practical. So how do I make this practical? Ladies and gentlemen, first of all, by solving this question that we have here, by solving this question that we have here, by solving the question that we have here. So the first thing that we need to do is to come and write here cumulative probabilities. The first step of ascertaining random number ranges is ascertainment of cumulative probabilities. So cumulative means adding them as you encounter them. So like now, cumulatively moving down, I can see the first probability is 0.3. So come and accumulate this here. If you accumulate it there, you'll end up getting 0.7. If you come and accumulate this, you'll end up getting 1, but you can't write 1 alone. because for simulation analysis, we have to be consistent. We must be consistent. We must be consistent with the decimal places. So it has to be 1.0. Now from there, I will come and pull out my random number ranges. I'll come and pull out my random number ranges. So how do I get this random number ranges? It's very easy. The thing that I need to know, how many decimal places do we have here? Emwe, moja. Only one decimal place. My values here are one decimal places. My values here are one decimal places. So ladies and gentlemen, what do I have here? If it's one decimal place, I'll be making use of only one digit. And the point that I was trying to explain, ladies and gentlemen, here is how do we get the upper limit? To define the upper limit, we read the number that is here as if it's a whole number. We read the number that is here as if it's a whole number 3. And then we deduct 1. So we read the number that is here as if it's a whole number less 1. So 3 minus 1 gives me what figure somewhere there? Gives me 2. Gives me 2. Please come to the second class. The second class, of course, I'm monitoring my number line. The second class will begin immediately after. We'll begin on the next number coming immediately after 2. On the number line after 2, we have 3. So look at what I will do. Here I will write 3 all the way to the upper limit. How do I get the upper limit? To get the upper limit, I will take this number as if it's a whole number, 7 less 1. So 7 minus 1 gives me what figure somewhere there? 6. From there, we got the next number after 6, which is 7. So 7 all the way to, I will read this as if the decimal is not there. I'll take this as if the decimal is not there. So I'll read it like it is 10. So 10 minus 1, 10 minus 1, that will give me what here, somebody? 9. And you can see I'm now through with my ranges because my range should run from 0 to 9, like that. Now, ladies and gentlemen, I want to assume that you guys have not understood anything in this particular example, and I give you another variable. This variable, I will call it x. X which could either be 50 or 60. So please come and give us probabilities. So you're given these probabilities here, pointer, for example, 1, 2, and then we have 0.88. 0.88. So this is example 2. Example 2. So with this example, and somebody comes and tells you to ascertain random number ranges, how do we go about these? To go about this, ladies and gentlemen, is a simple thing. The thing that I will have to remember is that number 1, we must provide cumulative probabilities. So do we have cumulative probabilities? Is there somebody who can accumulate for us? Please check. I can see somebody saying not clear. Are you able to see my board clearly? Are you able to see my board clearly, somebody? Aha, yes. Thank you very much. Thank you very much. Perhaps the one who is not able to see my board very clearly has a problem with his or her network. Thank you very much. So now here we are. We have our question here. So with our question here, now that they want us to give them random number ranges, the first thing that we will do is to come and ascertain cumulative probabilities. So come and ascertain cumulative probabilities. Ascertain cumulative probabilities here. Ascertain cumulative probabilities. So cumulative probabilities, we shall get them moving downwards as we add them up, as we encounter them. So in this case here, this will be 0.12. When I add this here, I'll end up getting 1.00 if I'm not wrong. I can't just say 1. We must be consistent with our decimal places. Now, ladies and gentlemen, having gotten this, I would want to see whether there is any single student who will be able to give us random numbers, random number ranges for this. I'll just take like 1 minute. Yeah, I can see some students who are already giving us the answers. I can see Lokai. I can see Denise. I can see, yeah, all of them actually. What they have done, they have told me, given that these are 2 digits, 2 decimal places, so 2 digits. So you're talking of 0, 0, all the way to 12. 12 minus 1. 12 minus 1, that gives us 11. Ladies and gentlemen, from there after 11, the next number after 11 is 12. So we talk of 12 all the way to 100 minus 1. So 100 minus 1, that gives me 90 what here? That gives me 99. 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 Now, thank you and thank you very much. How about this one? How about this one? How about this one? And this one is basically dedicated to any student from Summit who has just joined us to see whether they're together with us. So we have here random variable y, where we have 10, 20, vis-a-vis probabilities. We have 0.20, we have 0.80. Somebody from Summit should be able to give me random number ranges here. Somebody from Summit should be able to give me random number ranges here, kindly. So somebody from Summit should be able to give me a figure for ranges. Should be able to give me a figure for the ranges. Should be able to give me a figure for the ranges. Should be able to give me a figure for the ranges. Let's see. Let's see. Let's see. Yeah, so we have someone from Summit here. That is Yusufu. We have Hillary. These are brave students. They just came in and they've been able to knock out this concept very fast. Thank you very much. The first thing that they have done is to come and give us cumulative probabilities. So the cumulative probabilities, what do we have? We are adding these figures downwards. So we have 0.20, we have 1.00. Now, given cumulative probabilities, the next thing that we shall do is to come and ascertain the random number ranges. So random number ranges always go together with the decimal places. So for sure, like they told us there, we shall be having 2 digits. So 2 digits, don't say that this 0 is insignificant. No, to us, they are significant. They are very much significant. So 2 digits, we talk of 00 all the way to, we have this figure being taken as if it's 20. So 20 minus 1, that gives us what here, somebody? 19. And then now we have the next number after 19 is 20. So 20 all the way to 100 minus 1. 100 minus 1 gives us what here, somebody? Gives us 99. 99 like that. So then how do we apply these things in our past papers? How do we apply these things in our past papers? So let's go to our past papers, ladies and gentlemen. We start with December 2017, question number 3. December 2017, question number 3. For those of you who have already bought these books, RSAM revision kits, it's basically page number 216. Page number 216. Page number 216. Page number 216. December 2017, question number 3. Question number 3. December 2017, question number 3. Is there somebody who has been able to reach there? Is there somebody who has that question? Is there somebody who has that question? Someone who has that question? Yes. Thank you very much. That is coming from Lokai. Lokai happens to be good in these papers, even FM, very fast. Thank you very much. Keep it up. Okay. So, ladies and gentlemen, we are told here, if we have gotten that question, the management of New Era Company Systems Limited is planning to launch a new product branded Zimsang. The fixed cost of Zimsang is 80,000. However, the selling price variable cost and annual sales volume of Zimsang are uncertain. The below relates to product Zimsang. So they have given us unit selling price, we have variable cost, we have sales volume in units. So they want us to simulate the average profit of product Zimsang on the basis of 10 trials using the following random numbers. Using the following random numbers. Ladies and gentlemen, simulation is basically a two-steps process. Simulation is a two-steps process, yes.
Someone wants a screen share.
Screen sharing, the very best you could do is to send this question to you through WhatsApp, kindly. Kindly, anybody who has got this question on WhatsApp, kindly take a snapshot of this question and send it to us through our WhatsApp. I'm giving you exactly a minute. Try to share this through all the platforms of WhatsApp that you guys are in. Because I don't have this question on my screen. Next time, of course, I'll ensure that I put it up. To organize how you will get, they go for 1,000 Kenya shillings, 1,000 Kenya shillings, 1,000 Kenya shillings. So I don't know whether this student who wanted us to share the screen has been able to get access to this question. I know, of course, all of us are in some WhatsApp groups. What we simply need to do as good Samaritans is to take a photo of this question. We send it there. So the first thing that we need to do, ladies and gentlemen, for this question, step number one, is the random number ranges. So mention there for us, random number ranges. The first thing that we do is to give them what we call the random number ranges. The random number ranges. So random number ranges, yes. So random number ranges, what we do with this? Number one, we identify probabilistic variables. So probabilistic variables, which variables are these? We have the price. Unit selling price is probabilistic. It could either be 60, 80, or 100. And these guys have given us the probabilities. So we have here 0.25, we have 0.45, we have 0. What here? Somebody 30. And then they have given me variable cost. I can see variable cost is 20, 40, 60. And then I'm able to see my probabilities. So my probabilities, we have 0.25, we have 0.55, we have 0.20, right? And then I can see sales volume. Ladies and gentlemen, sales volume, we have 10,000, we have 60,000, we have our 100,000 there. And then, ladies and gentlemen, they have given me the probabilities of this. Probabilities, we have 0.30, we have 0.35, we have 0.35, like that. Now, ladies and gentlemen, I've just told you that the first thing that we need to do is to identify our probabilistic variables. So for those of you who have just joined us, this is December 2017, question number 3. December 2017, question number 3. So you say that the first thing is to identify random variables. The moment you identify these random variables, also called what here? Variable. They are variables, probabilistic variables. Variables here with probabilities. What we will do is to come and ascertain their cumulative probabilities. Please give me their cumulative probabilities, and you even go a step further and give me the random number ranges. That is your work. I'm giving you exactly 5 minutes. 5 minutes, you should be through with that. So ladies and gentlemen, here we are. So they want us to give them these cumulative probabilities. So we are adding them downwards. So this becomes 0.25. This becomes 0.70. We say here we have to be cognizant of the fact that we have to be consistent in terms of decimal places. So we have here 1.00. So come and give us a cumulative for this one. We have 0.25, we have 0.80 because we added this here. And then lastly, we have got 1.00 like that. So come and give us here the cumulative probabilities. We have 0.30, 0.65, and then lastly we have 1. What here, somebody? 00. And then once I have my cumulative probabilities, I will be able to pull out my random number ranges. I'll be able to pull out my random number ranges. So my random number ranges, ladies and gentlemen, because of the sensitivity in terms of decimal places, how many are they? 2. So my random number ranges can only be over how many digits? 2, 2, 2. So we start right away with 0, 0, all the way to the upper limit. How do we get the upper limit? It will be 25 minus 1. 25 minus 1, that gives us 20. What here, somebody? That gives us 24. Next class after this, we'll start after the next, the next number after 24. Next number after 24 is 25. 25 up to the upper limit. How do we get the upper limit? You take this figure as if it's a whole number, 70 minus 1. So 70 minus 1, that gives us 69. From there, we have 70 all the way to 100 minus 1. 100 minus 1 gives me what, somebody here? That gives me 99. And then we have got this one, which will be 0, 0 all the way to 24. 25 all the way to 80 minus 1, that is 79. And then we have got 80 all the way to 99. So 0, 0 all the way to 29. 30 all the way to 64. 65 all the way to what here, somebody? 99. And I'm so happy because most of you were able to get these parameters correctly. Now, ladies and gentlemen, from there we go to the next step, which is the step of the simulation what here? Worksheet. Give us a simulation worksheet. A simulation what here? Worksheet. Give us a simulation worksheet. Give us a simulation worksheet. So how will this simulation worksheet look like? My great students, this simulation worksheet will have here a run number. Run number. And in most cases, your examiners will tell you how many times to run. Your examiners will tell you how many times to run. Like this examiner told us to run 10 times. He told us we use 10 run trials, 10 of them. So we're going to talk of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Now listen and listen to me very well, my great students. For each run that you have, ladies and gentlemen, for each run that you have, there are 3 things that are troubling you. There are 3 things that you don't know with certainty, what values they are going to occupy. So these three things, the price, variable cost, we are not certain of them. And all the probabilistic variables that we have, like now here we have 3, they must be forecasted. How do we forecast them? Using random number. Each of these, you have to forecast it using a random number. So you come and pick the first random number, which will help us in this case here, ascertain the price. Pick the next random number for the second probabilistic variable, which is variable cost. Ladies and gentlemen, from that, come and pick the last random number, which will come and help us get the sales volume. The sales volume. So I'm repeating again that for each of the probabilistic variables that you have, you can only get estimations of that, their figures. And how do you get to estimate them fairly? Using the random numbers, which the examiner will always give us. The examiner will always give us those random numbers. Now the question is, ladies and gentlemen, are you able to see these random numbers which the examiner has given us? Is there somebody who is able to see the random numbers given by the examiner? Oh yes, like I can see, after required, use the following random numbers. The first random number is what, somebody? The first random number. The first random number. Kindly give me the first random number. What is the first random number? Yes. Is there somebody who is able to see a random number 81 there?
81.
81, yes. Please read for me the next random number so that I can fill the entire table with random numbers. Very fast, read for me the random number so that you can fill the entire table.
81.
32, eh? And remember, you can't write them downwards. We normally write them as per the runs. We finish one run to the end. So after 32, what is the next one given there? Oh, they're very random, so it becomes very hard for. So the better will be for Mwalimu to come and read them. So we have 81, 32. We have the next one is 60. I'm putting them on random numbers. After 60, ladies and gentlemen, the next one is 04. The next one here is 40 what here? 46. The next one is 31. Then we have 67, 25. 67, 25. 67, 25, 24. We have 10. 10, 40, 02. 10, 40, 02. 39, 68. 39, 68, 08. 59, 59. 66, 90. 66, 90. After that, we have 12, 64. 12, 64, 12, 64. 79, 79. From there, we have 31, 86, 31, 86, 68, 68. From there, we have 82, 82, 89, 82, 89, 25, 25. Lastly, we have 11, 98, vis-a-vis 16. The last one is 16 there. Now, ladies and gentlemen, after I've done that, now I can come and look for my parameters. I can come here and look for my parameters. Like now, what I need to ask myself is what will be the price when the random number is 81? When the random number is 81, I know where the ranges are. 81, my friends, falls here. If that is the case, then the appropriate price will be what here? 100. The appropriate price here will be 100. I can now even go ahead to variable cost. Variable cost with 32 random number. 32 random number, 32 is here. 32 is here, 32 is here. So we have got what here? Somebody 40. 40. 40. Just zoom in, they'll be able to see. Yeah. Yeah, that's okay, yes. So go to sales volume, ladies and gentlemen, you'll be able to see 60. Sales volume for 60, sales volume for 60. Where is 60? 60 is here. 60 is here, time to 64. 60 is encapsulated here. 60 here. So that gives me 60,000 units. 60,000 units. So could you be kind enough and go ahead and fill now the entire table with those values? And if you've got questions, ladies and gentlemen, please don't hesitate to ask questions. Don't hesitate to ask questions.
What are we doing?
There's a student asking, what are we doing? What are we doing? I want to imagine that the student has come in a little bit late. The student may have come in a little bit late. We are doing simulation analysis. Simulation analysis. Simulation analysis. We are doing simulation analysis, and you can see the question is up there. December 2017, question number 3. What I would request is that you hang in on there a little bit, because these students are almost finishing this question. And then when I start a fresh question, I'm so sure I'll be able to pick you up from wherever you are, from wherever you are. It's a new topic called simulation analysis. So great. So I can see somebody saying there that we are done. Let's compare notes. Let's compare notes. Let's compare notes. So what do we have here, somebody? 04 for price. 04 for price. I can see that is here. this range here, so that gives you a price of 60. 46 for variable cost. For variable cost, 46 is here. Variable cost of 40. 31 for volume. That again gives me 60,000. So 67 price, 67, that will give me 80. I can even finish prices. 10 will give me 60 here for price. 39 for price, that gives me 80. 59 for price, that gives me 80. 12 for price, that gives me 60. 31 for price, ladies and gentlemen, 31 for price, that gives me 80. We have 82 for price, that gives me 100. We have got 11 for price up there, that gives me 60. I can even capture this from down here. Variable cost 98. Variable cost 98, that gives me 60. 89, in this case here, variable cost. 89, that gives me 60. We have 86 variable cost, that gives me 60. 64 variable cost, that gives me 40. 66 variable cost, that gives me 40 again. 68 variable cost, 68 is here, gives me 40. 40 for variable cost, ladies and gentlemen, 40 is here. That again gives me 40. We have 25, the last one for me, variable cost, that still gives me 40. Go to volumes, 24 volume. 24 is here, the first one, that gives me 10,000. We have 02 for volume, 02 for volume is here, which again gives me 10,000. 08 will give me 10,000. 90 will give me 100,000. 100,000. 79 will give me 100,000. 68, ladies and gentlemen, 68 is here. It gives me 100,000. Gives me 100,000. 25 is here. That gives me 10,000. Then we have got 16, ladies and gentlemen, for volume. That gives me 10,000 like that. So let's read the question again. When you read the question, ladies and gentlemen, you'll be able to understand what these people are asking. Simulate the average profit. They want us to simulate the average profit. So whatever you've done is basically posting possible prices, possible variable cost, possible sales volume. But you see, at the end of the day, the examiner wants you to ascertain profit for each, to come and ascertain profit for each run. Now, my great students, whenever you see prices and you're able to see variable cost, question. Yes.
The first one is it 10,000 or 40,000? The second one is, second last is 60,000.
The second last is 60. The second last.
That's what someone is saying.
Somebody confirm, I could be wrong, I picked them very fast. Somebody confirm for me. Is this supposed to be the second last? Is this supposed to be 60,000? The second last.
So we're saying 10,000. No. Saying no, it's 10,000.
It's 10,000.
Then he was complaining about is it 10,000 or 40,000?
Which run, Liz? Which run specifically? Just tell me the run and then students will be able to evaluate.
The sales.
The sales, eh? Sales. For which one, somebody? For which one? Okay. Perhaps it's something you can even send it to me through WhatsApp and then I have a look at it. So whenever you see price and you see variable cost, ladies and gentlemen, and then
it's value is 40,000 and not 10,000.
From the past paper, the value is. At times, these past papers let's just work with the 10,000, one and the same. The concept is what is most important here. Where we have reached now, we can't go back again. So, ladies and gentlemen, come and talk to us here. Whenever you see price and you see variable cost, always think about contribution margin. So whenever you see selling price and you're able to see variable cost, always think about contribution margin approach of getting profit, where our profit will be equal to total contribution minus what here, somebody? Minus fixed cost. So remember this from your break-even analysis that you did some time back, that whenever you are able to see selling price and you are able, ladies and gentlemen, to see variable cost. For us to be able to get profit, always take your profit by getting total contribution. How do we get total contribution? By taking contribution per unit times number of units minus fixed cost. So how do we get contribution margin? To get contribution margin, we normally take price minus what here, somebody? Minus variable cost. So price minus variable cost multiplied by what your number of units minus fixed cost. So let us go through run number one. So run number one, I have here my profit being price minus variable cost multiplied by number of units minus fixed cost like that. Minus fixed cost like that. So come right away here. Are you able to see the selling price? The selling price that we have here is 100. The selling price that we have here is 100 minus variable cost, which is what here, somebody? 40. Multiplied by quantity is the volume. This is X. Multiplied by 60,000. And then we have a fixed cost. There was an original investment, which will not fluctuate with the number of units. The original investment, we are told, the original investment, ladies and gentlemen, for this question, the original investment, we are told was 80,000. We are told the fixed cost of Zimsang, up there, the fixed cost of Zimsang is 80,000. So to come and subtract here 80,000, 80,000. So could you be kind enough by giving me the first run profit? If run number one parameters are the ones to prevail, then run number one profit will be equal to what? Run number one profit will be equal to what, ladies and gentlemen? So anytime I see prices, I see variable cost, always remember that for you to get profit, we shall be using the contributions approach, where my contribution will be my selling price minus my variable cost, etc., etc., times number of units minus fixed cost like that. So there's a student giving me what figure, somebody there?
3,520,000.
3 million, I can put even my figures in shillings thousands, so that will be 3520, like that. Go to the second scenario. The second scenario, I can see price will be 60. Price will be 60. I can see variable cost. Variable cost will be 40. For scenario two, the number of units to be sold are 60,000. Minus the fixed cost. Fixed cost is ever constant, minus 80,000. So please give me a figure. We continue. 1120. So let's go in this case here to the third scenario. The third scenario, I can see my price is 80 minus, ladies and gentlemen, my variable cost here, which is 40, multiplied by number of units. If you work with mine here, 10,000 minus fixed cost, which is constant at 80,000. So please give me this figure. Please give me the next figure. 320. So 320, and please give me now all the other profit values. Give me all the other profit values. Give me all the other profit values. All the other profit values. What do we have down here? Number 4, number 5, number 6, like that. Let's give them time. They do the question until they finish. So, using the 10,000, the way I had them here, could you kindly give me the profits here? Give me the profits. So run number 4, who has a profit? Run number 4, who has a profit? Run number 4, who has a profit? 120. Run number 5. Please move with speed. Run number 5. Run number 5. What do we have there for run number 5? 320, yeah? So I'm being told here that run number 5 is 320. Run number 6. 39.20. 39.20. Thank you very much. Go to the next run. Quite a high profit.
1920.
1920, the year that I was born. Go to the next one. Go to the next one, ladies and gentlemen.
It's 1920 still.
The next one, I'm being told by my brother here that it's supposed to be 1920 still. 1920. Mm-hmm.
Then 320.
320, and then we have the last one. What is the figure of the last one? What is the figure of the last one? What is the figure of the last parameter?
Negative 80.
Negative
80.
80. Negative 80. So basically a loss of 80. And because they wanted us to give them the average profit, because they want us to give them the average profit, come and they give us the total profit. Down here, if I had space, I would have written it here. Come and give us, add all the profits here. Give me the total profit. 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 Please add up all of them. Those profits will amount to how much? Those profits will amount to how much? Add up all of them. So somebody who has been able to give us all the profits there. Somebody, if you add all of them up, what shall we get?
Different answers.
Different answers. I want the ones who use 10,000.
13,400.
13,000?
400.
400. Is somebody giving me a figure of 13,400? 13,400. 13,400. 13,400. So when you add here, you will get 13,400. Meaning that our average profit, so this is 13,400, therefore, our average profit will be 13,400 divided by the number of runs, which are 10. So 13,400 divided by 10, that will give us 13 what here? 1340 like that. That will give us 1340. 1340. 1340. So I would want to give you one, you try yourselves very fast. You try yourself very fast. The one of May 2017. May 2017, question number 4C. May 2017, question number 4C. May 2017, question number 4C, Pure Grain Society. Page number 217 of this revision kit. Page number 217. May 2017, page number 217. May 2017, question 4C, Pure Grain Society. So I want you to go through that entire question and simulate the profit for that company. So I want to give you exactly 5 minutes. So is there somebody who has been able to give us the average profit in that case? Is there someone who has been able to give us the average profit? This is fairly an easy question. I can see they've given me the selling price pattern. So I know that the first thing will be for me to give them the random number ranges, the random number ranges of the probabilistic variables. So the first probabilistic variable that I have there is price. So price, we have price here, which is 240, 250, 260, 270, 280, and then they have given us probabilities. What do we have here? Somebody 0.18, 0.29, 0.31, 0.14, 0.08. From there, we have yield per acre. We have basically the number of tons per acre. Number of tons per acre, ladies and gentlemen, we have 70, 75, 70, 75, 80, 85, 9. And then we have our probabilities. Probabilities, what do we have here? Somebody 0.09, 0.09, 0.16, 0.24, 0.38, 0.13. Then, ladies and gentlemen, I can see we have cost per acre, a whole acre, cost per acre. So cost per acre, we have 12,000, we have 14,000, we have 16,000, we have 18,000, we have 20,000, and then they have given me the probabilities. Probabilities, we have 0.14, we have 0.22, we have 0.33, 0.36, we have 0.26, we have 0.02. Ladies and gentlemen, the first thing that I will do, given this particular question here, is to come and give them the cumulative probabilities. So give them the cumulative probabilities. So please, we are accumulating downwards. We are accumulating downwards. So here we have 0.18. So please give me these figures. I wish I had a calculator. 0.18 plus 0.29. 0.18 plus 0.29. What figures are we getting? Somebody there? 0.18 plus 0.29. What figure are we getting? Somebody there?
0.47.
0.47 plus 0.31. I'm accumulating the probabilities. I am accumulating the probabilities. Because of time, please hurry up. Give me the figures.
0.78.
0.78, thank you very much, plus 0.14.
0.92.
0.92, and then of course, lastly, we'll talk over 1.00 like that. Come and do the same for the second variable. For the second variable, what do we have here, somebody? The first one will be 0.09 plus this 0.16.
0.25.
0.25, I'm being told, plus 0.24.
0.49.
0.49 plus 0.38, my great students here, what do we have?
0.87.
And then lastly, we have 1.00. Let's do the same for this other variable. So come and give us cumulative probabilities. So we have 0.14.
0.36. 0.72.
Thank you very much. I add this to this.
0.98.
0.98, yes. Lastly, we have 1.00. Lastly, we have 1.00. Thank you very much. So having gotten cumulative probabilities, we know what to do next. We know that the next thing will be random number what here? Ranges. So we have the random number ranges. So random number ranges, these are 2 digits. 2 decimal places, 2 digits. So we have here 00 to 17. The next one will be 18 to 47 minus 1. 47 minus 1, what do we have here? Somebody 46. The next class will be the next number that comes after 46, which is 47 all the way to 77. And then we have 78 all the way to 91. And then we have 92 all the way to 90 what here? To 99. So we have here random number ranges. Random number ranges. So random number ranges, we have 00 to 08. We have 09 here to 24. We have 25 to 48. We have 49 to 86. We have 87 to 99. So come and give us random number ranges here. So random number ranges, we have 0 to 13. We have 14 to 35. We have 36 here to 71. We have 72 to 97. And then 98 to 99. And then I'll come and give us the last thing, which is called the simulation worksheet. So remember simulation worksheet, what we have? We have our run numbers here. We have run numbers. How many runs do they want us to move? As the examiner specified the number of runs? As the examiner specified the number of runs? 8 runs. So we'll talk of 1, 2, 3, 4, 5, 6, 7, 8. So remember, the concept is very easy. For each of the runs, ladies and gentlemen, estimate the probabilistic variables. And how do we do the estimation? You'll pick a random number given by the examiner. You get the price, the first variable. You pick the next random number. You come and give us the number of turns. You pick the next random number. Next random number will give you the cost per acre. And then, of course, lastly, you need a column for what here? For profit. You need a column for profit. The last one, we need a column for profit. Now, ladies and gentlemen, please go ahead and pick those random numbers the way they have been given there. So the first one, question.
How do you know the runs are 8?
It's given in the question. How do we know the runs are 8? Given in the question, either given the question, and if not given, you need to exhaust all the random numbers given. You need to exhaust all the random numbers given. So it's either the number of runs are given in the question. Like now here, look at this question, May 2017 required. Use 8 trials. Those are the number of runs. Use 8 trials. Those are the number of runs. Thank you very much for that question. So we have, ladies and gentlemen, random number one. Random number one, what are you able to see under random number one? Random number one, what are you able to see under random number one? So random number one, we have 0 what here? 03. We have 03 here. So 03, so we have 03. Next random number is 91. Next random number is 91. After that, the next random number is 38. Now listen and listen to me very well, ladies and gentlemen. Listen and listen to me very well, ladies and gentlemen. So 03 gives me what price? 03 gives me what price? 03 is here. It gives me a price of 240. 91 gives me how many turns? 91 falls here. 91 falls here, which gives me number of turns are what here? 90. From there we have 38. 38 will give me what cost? 38 up there. 38 is here. It gives me a cost of 16,000. So ladies and gentlemen, in this particular case, how am I going to get my profit? How am I going to get my profit? To get my profit, what I will do, I will talk over, to get profit, I will talk of revenue per acre minus cost per acre, minus cost per acre. So the revenue per acre, I'm able to see the price is 240. Price is 240, and a whole acre will give me 90 tons. Therefore, for the first run, I have 240 price times 90. Then they have given me the cost per acre. Cost per acre, they gave me 16,000 shillings. So could you kindly give me the profit which I'll get from my farming of this 1 acre kindly? Give me the profit that I'll get out of farming my 1 acre. Kindly help me out there. Give me a figure, somebody. 5,600.
600.
So what I expect you to do is to get all the other profits, ladies and gentlemen, and then you average them. Otherwise, thank you very much. I can see my next class. Students are really disturbing me. They want to get in. I'll be looking at you guys, checking on you guys in our next lesson. God bless you. Have a good night. I hope you have gotten something out of this.